Now, let's do this cut here. What is the lateral area of the hexagonal pyramid at the right, rounded to the nearest square foot? Here now, as you see, we have a pyramid. We need to find now the lateral area. We said before that the lateral area is half the perimeter times the slant height. Now, how can we find the perimeter of a hexagonal shape? And
I'm multiplying 6 by 36.
36, yeah.
And half times how many sides? We have 6 sides. And what is the length of the edge here? It's given
36.
36. Then, so I found now the perimeter. I need now to find the slant height. To find the slant height, where's the slant height? Is it this one? No.
No.
This is the apotheme of the hexagon. Is it this one?
No.
No, this is the height of the shape. This side, or this line segment here, is the slant height. So, now let's make a right triangle here. In this right triangle here, we have this one is a slight height. This one it's given, it's 18 square root of 3. And this one is given, it is 42. So I need now to find the slant height. 42, one of the legs, 18 square root of 3 is the length of the another leg. How can I find the slant height?
By Pythagorean theorem.
Pythagorean theorem. So the slant height squared is 42 squared plus 18 square root of 3 squared. Now, 42 squared plus 18 square root of 3 squared is 2736. Square root of the answer, you will find that the slant height is 12 square root of 19, or you can say it is 52.3. So this is now the slant height, or name it with L. We don't name it with H because H, it's mean the height of the shape. The slant height, we wrote it like slant height with letter L. Now, here it is.
It would be 52.3 feet, right? If we just say the little slant.
Yeah, I need only the 52. Then this 52, multiply it by 36. By 3, the answer is 5,648.4 square feet. Okay?
Okay, teacher.
This is now here how to find the lateral area in square foot. It is 5,648.4 square foot. Is it clear now? Do you have any question?
No, teacher.
No, teacher.
No.
it's a curve lateral face. So both of the cone and the pyramid, they have something in common, that they have only one base. It's not like the prism and the cylinder, which they have two bases. So this is the cone. They have the same thing, one base, but and here now the base is not a polygon, the base is a non-polygon shape, which is a circle. So the cone now have a circle base. And the lateral faces here are not triangles, it's a curved lateral face. They have the same thing. The altitude, the length here of the altitude that is perpendicular on the base is the altitude, or h, the height. And the length of the altitude of the lateral face is the slant height. And they have a meeting, all the curves, they are meeting each other at one point. We call it a vertex. So, like a pyramid, a cone is a solid that has only one base and vertex that is not in the same plane in the base. What does it mean? That means this is the plane of the base and this is the plane of the vertex. They are not on the same plane. The base of the cone is a circle. It's not like the pyramid, which is a polygon. It's a circle. In a right cone, the altitude is a perpendicular segment from the vertex to the center of the base. Perpendicular from the vertex to the center of the base. Now, the height h is the length of this altitude. The slant height, we name it with L, is the distance from the vertex to a point out on the edge of the base. Any point, so it is a line segments that connect between, it's a segment or line segment that's connect between 2 points. What are these? I'm sorry. What are these 2 points? So it's connect between 2 points. This is the first point, and any point on a circle. So this is the slant height. This is now the slant height. This is now the slant height. It is between the vertex and any point on a circle. Or we can say also it is the altitude of the lateral face. Now, in this book, we assume that the cone is right cone unless we stated or pictured otherwise. Okay. So for the pyramid, we will assume that it's a regular pyramid. And for this one here, we assume it is a right cone. Now, let's learn now how can we find the lateral and the surface area of the cone. Now, as we talked, or as we said before, that the lateral area for the pyramid or for the cone, it is half the perimeter times the slant height plus one base, because only we have one base, so I need to add it to the area of the base. So the lateral, the surface area here is the summation of the lateral area plus the area of one base. One base, because already we have only one base. So this is now also the surface area of the cone. Now, you say it is half the perimeter times L. Since now here, it's as the same as or like the cylinder. Since now we have only one of the base, it cannot be square or pyramid or like the prism. It cannot be again, the shape is not the same like the prism and the pyramid. It's only one shape, which is a circle. So it's very easy to me to say that. Since now the surface area is half parameter times the slant height plus the area of the base. Now, since we have a circle, so it has only one parameter without looking at the base. What is the parameter of a circle? It's 2 by
2 pi r.
r. This is for the base. Now times the slant height plus, what is the area of the base? It's by
r squared.
r squared. Then, so the surface area now of the surface area now of the cone is by r L times by r squared, by r L times plus by r squared. Now, so if I want to find the surface area, I just need the radius of the circle and the slant height. This is now for the cone. Is it clear?
Yeah.
Yes.
Okay.
But teacher, why is it half the perimeter of a circle? Like in the formula.
The formula, it is half. You mean why the formula is like this?
Yeah, why is it half? Like in the pyramid, because the lateral area is a triangle, so I understood half based on its height. But in a cone, why is it half?
Maybe the pyramid is like the cone. Why? How can you understand that in the pyramid? You know what's half. Why half? Why it's half in the pyramid?
Because the lateral area is that of a triangle. And the formula for the area of the triangle is half the base multiplied by the height.
Okay, here, by the way, calculus, the calculus, if you look at them, you can find like this one example here. Okay, now all of us know that the area of, or not the area, sorry, the volume okay, the area of the circle, all of us know that the area of the circle is by r squared. Okay, then after that, do you know that do you know what's the volume of the sphere?
It's 4/3
by r
cubed, yeah.
Okay, I will tell you now from where they bring this number, this formula. They say that we imagine now we have 4 circles that are connecting with each other. So that's why the area or the surface area of the sphere, it will be 4 by r squared. This is for the surface area. By the way, later on we will talk about it in another lesson. So this is for the surface area of the sphere. From where they bring the volume? In calculus, we have two things, the derivatives and the integration. Okay? How can you find the integration? To find the integration, wait, please. To find the integration, its rule is integration of n, or not n, x raised to the power n is x. This mean is an integration. This sign, it's like this. It's x n plus 1 over n plus 1. This is how can we find the integration of any expression. Now, how it can help me? We said before that the surface area is 4 by r squared. Now, then, and we said also that the integration of x raised to the power n is x raised to the power n plus 1 over n plus 1. So the volume here is 4 by, since they are constant, so inshallah we'll talk about them in grade 11, but since they are constant, you will put them outside. You only find the integration of the variable, which is r. Here we have r squared, so its derivation, its integration, here we have r squared, so it will be r to the power 2 plus 1 over 2 plus 1, which is r cubic over 3. Then if you rearrange it, you will find that the volume is 4 over 3 by r cubic. This is a way how they find the volume. So the calculus is or can help you, or they help the mathematicians before, how they find the area and the volume, and also be in physics the acceleration, the velocity, and so on. That the derivative of the acceleration, this means the derivative of the acceleration is a velocity, and the derivative of a velocity is a distance. Here also the same. The derivative of the volume is a surface area, and the integration of the surface area is a volume. And that's why, so because I mean that that's why they have a half PL. They have a formula. This formula they found, they have it, and then they found its derivation to find that it was half PL.
Thank you a lot.
I mean, it's like this. Wait, please. Try. It is, they thought like it is they talk about the lateral face of the pyramid. The lateral face of the pyramid here. Sorry. They saw that, imagine that it is P. This is for the lateral face. Now we said, and I think that it's like P times L. This is for the area of it. The parameter times L. Now they find its integration, which is P raised to the power 1. It will be P raised to the power 2 over 2. That's why, no, it cannot work. It will be half P squared L. So I think there's a formula. I cannot remember. It's not PL. I think it's not called this PL. There's a formula that if they can define its derivation, they found the surface area of the the lateral area of this cone. Okay, so some formulas are coming from calculus, but this calculus we will take it in grade 11 and 12. This calculus, they solve everything. They told me from where I bring the velocity, from where I bring the acceleration. So you not talk about them. This, inshallah, if you will go study calculus or engineer or be at mathematics, physics, science, also on you will talk about how can we find, or how can we derive or integrate these formulas. Now back to our lesson. I think if you want, you can find it on the Google. You will can understand from where we bring this half.
Thank you a lot, teacher. It's very interesting.
You're welcome. So this is now for the surface area. It is pi RL plus pi R squared. So to find now the area, the surface area of the cone, we need only the radius and the slant height. If you bring these two magnitudes, you can find the surface area of the cone. Let's copy back here now. So the lateral area of the right cone is half the product of the circumference of the base and the slant height of the cone, which is half times 2 pi r times L, or pi r times L. The surface area of a cone is a sum of the lateral area and the area of the base, which is pi RL plus pi R squared. Let's now do this example here. Can we? Oh, the period is finished. Oh no, thank you. The period is finished. I will continue tomorrow. Do you have any questions?
Thank you a
you.
lot.
Thank you. Have a nice time.